Hi there and welcome to today's class. Let's look at physics, a topic called equilibrium of particle. Last class we dealt with the concept of vector in 2D, how to resolve vectors in 2D. So proceeding, we're looking at the concept of equilibrium of a particle. Let's look at definition of equilibrium. What equilibrium? First is first, by definition. Equilibrium, this occur when there is no change or observable change in the property of the particle. That's how you define equilibrium, right? We said this occur when there is no change or observable change in the properties of the particle. That's basically how you define equilibrium. The next concept is that there are types of equilibrium. So there are different types of equilibrium. The first one is called the static equilibrium, and also we have the dynamic equilibrium. So let's look at the concept of types of equilibrium. The first one I have here says static equilibrium. Let's explain static equilibrium. What is static equilibrium? Static equilibrium is an equilibrium achieved when a body is not moving at rest. So I'm saying that static equilibrium is an equilibrium achieved when a body is not moving and at rest. Right? That's basically how you define static equilibrium. Let's discuss number 2 called dynamic equilibrium. By definition, this is equilibrium when a body is moving but moving at a constant velocity and hence there is no acceleration. That's basically how you define dynamic equilibrium. So we have dealt with definition of equilibrium and each types of equilibrium and we have explained them. Let's look at the condition or the laws of equilibrium. When it comes to equilibrium, there are basically 3 conditions of equilibrium. We have number 1 is called the summation of horizontal component is equal to 0, right? That is summation of f of x equal to 0. This is my first condition of equilibrium. Number 2 says that the summation of vertical components is 0. That is f of y equals 0. Finally, I have the third condition of equilibrium, which says the moment about a point equals 0. These are the 3 conditions that governs equilibrium. So I'm saying these are the 3 conditions that governs equilibrium. We'll now use this idea and this concept to solve some problems and see how we can possibly handle problems under the concept of equilibrium of a particle. Welcome guys. I just launched a course. The course will teach you how to start your own YouTube channel. If you're a teacher also trying to do what I'm doing, you can get this course. The course costs about just 10,000 naira. You can get a course and you start uploading your videos on YouTube. Or if you're a beginner trying to explore YouTube and you're having interest in learning how this YouTube of a thing works, you can do well to get this course. As you can see the banner of this course in the video, in the screen of the video, right? So do well to go and get the YouTube course so you can earn, learn, and also grow your platform. See you guys. If this interests you, do well to message me up or click on the link you see in the video description that says YouTube course. See you guys in next page. Hi there. Are you a candidate for the upcoming 26 JAM/WAEC examination? If yes, then I want to invite you to my JAM and WAEC tutorial class. In this JAM and WAEC tutorial class, we'll be looking at several topics such as mathematics, chemistry, and physics. For each of these topics, we'll be doing an in-depth teaching as well as solving past questions for the last 10 years for each of the topic. If this interests you, do well to click on the link you see in the video description, or you can message me up through my WhatsApp number as displayed in front of you. See you guys in the next class and welcome to Excellent Link Academy. Welcome back. So let's solve example 1 under the study of equilibrium of a particle. example 1 says, the question attached to this diagram says, determine the tension of chord AB and AD for equilibrium of the 10 kilogram block shown in the diagram above. So this is the diagram attached to that question, please. So first things first, we are asked to find, it says, determine the tension in chord AB. Tension is more like a force, right? So a tension is simply a force that acts on a string. So by the word tension is like a force that occur in a rope on a cord. So this is a cord here. A to B is a cord, is a rope. A to, sorry, here is C, here is D. So A to D is under cord, right, under rope. So there's a force here called force AB. A force is here to cause force what? AD. So the tension on AB and AD is called the tension. So we're asked to find the tension in chord AB. So this A to B, this line here, I'm asked to find the tension force there. Also an AD. So AD too, I'm asked to find the tension force. What do? My first task here is to draw out the free body diagram. If it's your first time hearing this word, free body diagram, this means free body diagram is simply a diagram that shows all the external forces acting on a structure or on an object. That is, so if I'm to draw this man this way, this center point here is this one here. If you observe closely, I have, so I'll call this line here is this one you are seeing here. I'll call it tension of what? AB, right? TAB, I'll call it TAB, right? And TAB is inclined to angle 30 degrees to the horizontal at this point here now. So this chord here, this line here is a line AB. This is, I have to find tension at AB. So this is called TAB. Tension at AB, this line tension at AB. Next up, you see this line, this one here. This is your mass, right? We expect that this one should be a weight, and they give me mass. So the mass was given as 10 kilogram. But we said this one is a tension, is a force. This one should be a force. It should be in Newton. So how do I convert mass to Newton? It's easy as weight is equal to mass times gravity. Mass is 10 times the gravity I'm using here is 9.81. Gravity is constant. Multiply these two, I'll have 98.1 Newton. So the weight I'm using now, so the W here becomes what? W, the weight, which is of course 98.1 Newton as my weight. Of course, at this point here, if I draw this line here signifies tension at what? AD. At AD. So we are asked to find TAB and what? TAD. We have to find tension at chord AB and AD. So let's get this done, please. First, to solve this problem, I have to apply the condition of equilibrium. So the first condition says that, so first condition, let's do summation of horizontal, this summation of horizontal component, that's of course summation f of x equals to 0. First things first, we said our first task is that let's do summation of horizontal component. So here's the idea. If I resolve TAB to the horizontal component, if I resolve T, so here's the idea. This concept follows what we have learned so far, which is called how to resolve vector in 2D. So if I resolve TAB to the horizontal, that gives you a cos, right? So this one gives you summation of x, summation f of x will be equal to, first things first, resolve TAB to the horizontal, that gives you TAB cos, of course, 30 degrees. That's my first task. Outside that, this is horizontal too. So this is going towards negative portion. That gives you negative x direction. That is minus what? TAD. All right, I have this place. All right, minus TAD. I have this. All right, I have this place. So equals 0, equals 0. I have this. So from here, I will have that. I will have that. Perhaps if I want to, I will have that TAB cos 30 minus what? TAD equals 0. I'll call this term equation 1. Why? Because I did not know TAB and TAD. So I can't look for two things at the same time. I'll call it equation 1. This is my first condition. Done. Second condition says summation of vertical component equals 0. That's summation of f of y equals 0. Take upward as positive. In this case here, if I resolve TAB to the vertical, that gives you TAB sine. The angle is there is 30. If you have watched our previous classes on how to resolve forces in 2D, you should know how I got to this. If I resolve TAB to the vertical, I will have TAB sine 30. Of course, this one is going downward. That becomes a minus W equals 0. Take W here, gives you, that can be written as W equal to TAB sine 30. Of course, we know that W is 89.1. So that gives you both W is equal to what? 98.1 Newton. That's W. I'll put W here. That gives you 98.1 equal to TAB sine 30. My task is to get TAB. So I have to divide both sides by sine 30 divided by sine 30. So it means this will cancel this. So I'm saying that the value of TAB, so TAB will be equal to 98.1 over sine 30. So TAB will be equal to, if I punch this on calculator, that should give about, this is 196.2 Newton. That is the value for TAB. So I've gotten TAB, tension at AB. The next one is to get tension at what? At AD. So let's get tension at AD. Since I've gotten TAB as 196.2 Newton, if you go back to equation 1, if I put TAB here, if I put TAB as being this value here, I can easily get the value for TAD. All right. Take this off. I will take this off. All right. I've gotten TAB as being 196.2 Newton. I want to get TAD. It's easy as putting the value of TAB here, and then I can easily get TAD. So I'll say put TAB has been equal to 196.2 Newton into equation 1. Alright, equation 1 says that I have TAB cos 30 minus TAB equals 0. From here, TAB is of course this value. That's 196.2 cos 30 minus, perhaps take this negative TAB here, becomes a positive TAB. Make TAB, perhaps point this calculator, point this one here and get the value of TAB. So therefore, TAB will be equal to 196.2 cos 30. That gives around, that's about 169.91 Newton. All right, this is the value of TAB and then of TAB and TAD. Please, the D. TAD. TAD. Please. TAD. So I'm saying this that the answer becomes TAB is equal to 196.2 Newton. TAD equal to 169.91 Newton. This is the value that we have to find for TAB and then TAD. So let's solve another example in our next video.
I just launched a book called The Shortcut to Academic Success. In this book, I share a lot of experience on how I evaluated during my time in school. This method really helped me a lot. If you're interested in getting this book, simply chat me up through my WhatsApp number that is shown in the screen